Right, so in AS you looked at a uniform distribution model, and that was the discrete uniform model, where every possible outcome that could happen over a range of events had an equal chance of occurring. So for example, when you're rolling a dice, you've got 6 possible outcomes, 1, 2, 3, 4, 5, 6, and nothing in between. You couldn't get a probability of rolling a 1.6 or a 3.4 recurring. They were discrete outcomes. Where we lead this to in A2 is where the context of the function that we're looking at has a continuous range of possible outcomes between two limits, and that is represented, if you imagine that we've got that what we're actually interested in here is the probability of something occurring between two values, two limits then, A and B. Now when you were drawing one of these in AS, you'd have spikes. So there'd be one there for throwing a dice of 1, 2, 3, 4. But in this instance, what you've got is a rectangle, because any value between A and B would have an equal probability. So what that means is that the total area of that rectangle is going to be 1, because as we've learned from right the way back to key stage 3, when we first meet probability, we know that the total combined probability is 1. So this rectangle must have an area of unity of 1. And what we've got here as well is that the probability that the outcome X is less than A is going to be 0. So the chances of any outcome smaller than that value is going to be 0. And similarly here, the probability that X takes a value greater than B also equals 0. So it's impossible to get a value less than A, and it's impossible to get a value greater than B, and in between any outcome is equally likely. So we've got the area of that rectangle is equal to 1, and what we have is that this distance here, so the width of the rectangle, is going to be B take away A. So this distance here is B take away A, and that allows us then to work out what the height of the rectangle is, which is the function, the probability function fx. So because the area equals 1, the area of that rectangle is going to be fx times, so the fx is the height, b minus a is the width, and that area must equal 1. So to work out the height, what each likely outcome is going to be, the height of that rectangle is going to be 1 over b minus a. So this is summarized in this section here. It's in green, which means you've given these formula. I'll show you in a moment. So this is saying that the probability of x occurring for any value of x is 1 over b minus a, where b and a are the limits of your distribution, and it is equal to 0 anywhere else. And then you're also given that the expectation, or the mean of the distribution, is the middle value, so a plus b over 2, and the variance is given by this expression, which we don't need to derive, and as I mentioned, it's in green, we're given. So here's an excerpt, one of the pages out of the WJC formula books. You can see here for statistics, you've got information about probability, and then you've got your discrete distributions that you met at AS, and then we come down here to the continuous distributions, and we've got the uniform distribution of x here. So the probability density function, which is your fx, is 1 over b minus a, the mean and the variance. Okay, so you'll be given those, you don't have to worry about finding those. So let's take a look at a group of examples on those now.